we're just given that R is the midpoint, and we want to find that SR equals 1/2 SV. So first thing is take our given information. R is the midpoint, so I know that these two segments are equal to each other because the midpoint cuts off the segment into two equal parts. Find where that statement's located, and that is my given. Okay. My next statement is SR, or segment SR is congruent to segment RV, so now I see that those are equal to each other, and they are by what definition? Again, make sure you use the exact term that's included in your proof. If you don't see the term somewhere earlier, then you cannot use it. Okay. The only exception to that would be definition of linear pair we'll use is based on the diagram. Okay, but everything else that's a definition, you have to have that word show up in your proof prior to the definition. Okay, now if I convert from congruence of segments to equality of their parts, SR is equal to RV, okay, what defines or what justifies that statement? Okay, so definition of congruence. Again, we see the congruent symbol here. By definition, congruent means equal in all respects, so their measurements are going to be equal. Move to the next statement, SR plus RV equals SV. Okay, so again, is this the structure that could be segment addition? Yeah. Right. Well, so we introduced it in this step right here. So now that it's in our proof, we can use the definition for that. Okay, so when we come back, statement 4, it does fit the structure of segment addition, so let's test it and see if it is. So is it SR plus RV is equal to SV? Is that the sum of the parts equals the whole? Yeah, so we can identify this as segment addition. Now notice statement 5 fits that same form, okay, but it has SR plus SR equals SV, so again, more than likely, if it's not segment addition, because this is not SR plus SR equals SV, it's probably going to just substitute an equivalent value in. So if I look at my statement from step 4, the only difference is I replaced RV with SR. Can I do that? Yes, so that's going to be straight substitution. Okay. Finally, here when I combine SR plus SR is equal to SV, all I did right here is added or combined like terms. Okay, now I will tend to use addition properties different than addition. Okay, so if I put addition, then I will likely just be that I'm combining terms on the same side of an equation. If I use addition property, it's the axiom that if equals are added to equals, then the sums are equal. That's where you would add the same thing to both sides of the equation. So that's why, again, in something like this, I will probably have a statement like combining like terms, okay, if it's just working on one side of the equation. Once I get to that step, I can now isolate my SR by either dividing by 2 or multiplying by 1/2. Okay, you have to be able to distinguish either of those. Okay, more than likely, I'm not going to have an option for both, so it's going to be one or the other. So even though it looks like it's 1/2 times SV here, all I did is I took equation 6, divided both sides by 2, and so more than likely it's going to be division property. Oops. But it is possible it could be multiplication property, multiply by the reciprocal, but again, I will tend to use the more straightforward math operation, the one that undoes the process.